Hello. In this video, I'm going to show you how to design and build your own do-it-yourself attenuator for guitar use. It's the year 2022, the year of the tiger. I like tigers, and I have already built attenuator here with the background of a box of vintage cartridges. The topology of the attenuator in this video will be a pi attenuator. It's called a pi attenuator because the resistors that compose the attenuator resemble the letter pi. So in an attenuator, there's a few things we have to do. One of them is to attenuate the voltage. So this pi attenuator acts as a voltage divider. So this is the input, this is the output. This voltage will always be less than this input voltage. And lastly, when we look into this network, we want to see the characteristic impedance Z0 of the system. So if it's an 8 ohm system, for example, we would like to see 8 ohms when looking into this system. Otherwise, we would disturb the correct impedance, and that's not very good. So in this picture, I have the pi attenuator connected to an 8 ohm speaker. So we have to select the values of R2 and R1 such that we would see 8 ohms on the left. This left is the amplifier hookup. So if this were a 16 ohm system, like a 16 ohm speaker, you would want to design these resistors so that you would have 16. In cable TV, that would be 75 ohms. Most RF systems are 50 ohms. So depending on the characteristic impedance on the right side, you would design it such that you would see this impedance on the left. And I will show you how to design for that on the next slide. So over here I have the equations for designing a attenuator up here, and basically R2 are the same on each side, and the equation is the characteristic impedance. In this case, I'm designing for an 8 ohm speaker system, so that will be 8 ohms here. And then the attenuation level, I chose 17.6 such that I can get the attenuation level I wanted and reasonable resistor values which are close to standard. So you would plug in these values, 8 in your attenuation, which is A up here in dB, and into this equation. So it's basically 10 to the power of your attenuation in dB divided by 20 plus 1 divided by 10 to the attenuation in dB over 20 minus 1, and I won't read out the R1, but it's over here. So when you're choosing these resistors, you have to make sure you have enough power capability in them. The wattage of them should be good enough to handle it, your power amplifier. In my case, I am intending to use this for a 5-watt amplifier, so I chose resistors which were 10 and 15 watts rated. And as resistors do get hot, they do derate in the wattage. So that's another thing you have to take into consideration. About dBs, so every 3 dB in power is means half power. So like I said, I'm going to use this for a 5-watt guitar amplifier. So 5 watts is 37 dBm, and the way I know that is, I know 10 watts is 40 dBm, so 3 dB less is 5 watts. And then if you subtract 17.6 from 37, you get the actual power level that is coming out of the attenuator, the other side of the attenuator on the V out side. So if you're not comfortable with dBs and dBms, you can probably find an online calculator to help you out. And actually, these equations, you can probably find an online calculator somewhere to help you out with the values. And to do this, it's good to maybe put it in Excel like I have done over here, so you can play around with your attenuation numbers and see what kind of standard resistors you get. So now onto the build. For the build, you would need two input and output jacks, and you need to identify where your signal and grounds are on them. On these jacks I'm using, these 1/4 inch jacks, the signal is here, the ground is on this side. So for the build, I'm following this schematic here, R2, R2, R1. These are my two R2s, and R1 is on the other side. You cannot see it, but it's right on the other side, connecting the jack inputs to the other end. So the R1 would go from here. This is my jack input to the other side of the jack input. You cannot see on the other side. The R2 goes from one input. So this is, let's say this R2, and then it goes to the ground of the other jack on the other side, and likewise for this R2. So we're building this section here, and this is your external speaker connection. And incidentally, the way I'm building this, it's symmetrical. So these R22s are exactly the same power ratings. So you can switch the ins and outs. It would make no difference. This is a symmetrical network. As long as the power ratings are the same on the resistors, you can interchange the input and output. And as you can see, my 10 ohm resistors don't really match with the calculated values. These were the closest values I got. And likewise for R1, you won't be able to find a 29.82, so choose the closest value if you can to this calculated R1. So in this build, I'm using a 1590A enclosure, which you can pick up for less than $5. So this whole thing should cost you less than $10 because these the jacks which I'm using are less than $1, maybe about 50-60 cents each, and so are these power resistors. Now this may vary from case to case depending on what your source is and availability, but it should be pretty easy to build one of these for less than $10. One point I like to make is I'm using this aluminum enclosure also for its ground. So the jacks, the 1/4 inch jacks, their ground is connected to this aluminum case, which is a ground. So everything, my ground reference is this aluminum case. So basically the ground on this side of this jack is connected to this jack by means of this case. So these two R2 resistors were just connecting to the grounds of the other side of the jack. So if these do come loose, you will lose your ground. If these jacks do come loose, you will lose your ground. Well, with that in mind, you may want to take an extra safety measure to connect the grounds of each jack with a piece of wire to the other side. But I didn't do that. Another important thing to note is to make sure that these signal pins on your jacks don't short to the metallic case. So with that in mind, I have electrical tape all around the inside of my case, especially where the inputs are, the jack connections are, and also on the lid. So I have electrical tape isolating the lid just in case this jack does hit the lid. I think I have enough space between this jack, so when the input comes in, it doesn't hit this. But regardless, I did put electrical tape, and I would suggest for you to do the same if you decide to use this procedure or this method. Lastly, just make sure when you before you close the lid, nothing is shorted, straighten things out. Stick a guitar cord in here, make sure it functions properly. There's enough room for it to go in on each side. And if nothing is shorted, go ahead and close the lid, and you should be all done.